Cool. So today we are going to be covering how to read code, which is a very crucial skill for any software engineer or developer. And it may seem like a very simple question, how to read code, but I think the simplicity can be a little deceiving. Let me share my screen and we will dive right in. I want to make sure I'm getting the entire browser. Let me know if you can see me switch tabs. Yes, cool. Okay, how to read code. We're going to start by going through a simple repository. There is an npm package called array equal. Apparently, you've already used it in the linear search and Armstrong numbers algorithm challenges. So let's take a look at this repository. Well, first, before we get to the repository, we're looking at uh, the npm page for this. So npm, you should already be familiar, is Node Package Manager. It's got a very playful website that changes its little I forget what they're called. Um, Whatever the three letters are at the top of this, so it's very cute. What it is it's a collection of npm modules, packages that you can install on your local machine, and it has pretty good documentation about all the necessary data related to these packages, like the repository that they come from, and some statistics on how popular they are, and links to fund a package if you're interested in supporting these developers. So we have a very simple package here, array equal. All this does is it checks if two arrays are equal. So that's great, but how does it work? Let's take a look at the GitHub page. When we get to the GitHub page, we get our basic instructions, which, like for all of these other npm packages, is to run an npm install command. And then it talks about the usage. If this looks familiar, it's because it's pretty much the exact same thing we have in here. So who would like to say in their own words what this means?
Are you saying like what the usage block is supposed to be, or are you saying like what the actual code means?
Either or, how you read it, how you interpret it. Like, let's say you just stumbled on this as a developer, you're trying to understand what it does. Well, what does it do?
Okay, yeah. So if I mean, obviously the install part is just like how to get it, and then the usage is just some basic examples on what expected outcomes would be, and kind of like the syntax for this specific package, I guess.
Right on. That's pretty solid. That is absolutely correct. If we were to take it a step further, we can do that by diving into the code to see how it works beyond what it's showing us. So usually your entry point to a code base, it's going to be dependent on the framework that you're using, but in a lot of cases, it's going to be index.js. Here, for example, is our entry point. So we see off the bat that we have some notes from the commit history, like it requires Node.js 18. There was a move apparently during one of these commits. If we go to the actual code, we see, because it's export default, we could assume this is the primary function of this script, and that function is array equal. Array equal is a function that takes in two arguments, array1 and array2. It then creates a length constant, which is equal to array one. And it looks like it's actually an object. So if array one is equal to array two, then we return true. Otherwise, we check to see if the length is equal, in which case we return false. And then we validate this by iterating through these arrays. So we start at an index of 0 until we reach the length of the array, we increment by 1. So if the value at the index of array 1 is not equal to the value at this index of array 2 at any time, then we return false. And if it passes all of this, we get to the end, and then it returns true. Any questions?
I have one question. So is the reason why on line 8 we check for whether the arrays have different lengths? Is the reason for doing that check to have like a really quick way to identify any differences without having to dive into what is actually within the arrays?
Exactly, exactly. So whoever wrote this thought it would be convenient to be able to do a quick check before we actually run the more expensive search of looking through the array. So it's one way the engineer was able to write this code in an efficient manner. He made it to be efficient and quick and fast. So that's exactly what that is for.
Okay, thank you.
Cool. Look at you guys. You all are learning to read code.
What's the code on line 2? What exactly is that for?
That's, I don't know. Why don't you tell me?
No, I really don't know.
Okay.
It seems useless to me.
Sure. Well, let's see where this length is being called. So first we're defining length and we're setting it to array 1. And then we call the length again to compare it to the length of array 2. It might be the syntax. Well, actually, before I even go there, yes, the syntax might be a little confusing because it's different to how we're calling the length of array 2. But I believe the length is also used in this line here. But I see what you're saying. We don't have to actually define this length, right? Because we could at any time just call array1.length.
Why is it in curly braces?
That's another good question. My first thought was this would create an object, but I don't think that's the case here. I think what's happening, I'm assuming that it's going to have something to do with how constants typically are not mutable. But I don't know where to go from there. I'm not quite sure why the programmer wrote it this way. Let's take a look. Let's ask, well, first we can do a quick Google search. So let's say in JavaScript, constants wrapped in curly brackets. What does that mean? So we know that curly brackets are used to deconstruct an object. So that was my initial thought, but I was stuck because I didn't know how rendering this as an object necessarily helps us further down the code. So let's dig a little deeper. Nice. Let's see. We aren't working in React, so let's skip that. In JavaScript code 1, object equals key value. But that doesn't seem to be the way that we're using this in this case. So is there something that is happening that we don't quite understand? These are all very good questions, by the way, and that's exactly the kind of questions that you should be asking when trying to read and decipher code. So let's say I've looked through a few websites. I still don't have quite the exact answer. That's where ChatGPT can now come in. So let's say for my prompt, I want to ask ChatGPT, I have some code that I want to understand. Can you explain the second line of this code for me? And let's pass it in. This line is using destructuring assignment in JavaScript. Destructuring assignment allows you to extract multiple properties from an object or elements from an array and assign them to variables. In this case, array 1 is an array passed into the function as a parameter. The curly brackets indicates that we are extracting the length property from array 1. So length is a variable that will hold the value of the length property of array 1.
Yeah,
One.
it seems
That-
kind of like circular logic.
It
Like,
does.
Yeah.
That's
Yeah, it's not
exactly.
necessary. Yeah.
So, okay. So now, then, if that's the case, let's ask ChatGPT, couldn't we also just assign the length of array 1 to a variable like const array length equals array 1 dot length? All right. Absolutely. You can certainly use that to achieve the same result. The line with the curly brackets is another way of extracting the length property of array 1 and assigning it to a variable called length. It's a concise and shorthand way to achieve the same result, leveraging destructuring assignment syntax in JavaScript. Okay. So the other way is equally valid and often more explicit in terms of what you're doing. So it's a matter of preference or the coding style you're following. Both approaches achieve the same outcome. What is the exact advantage or benefit to using destructuring in this case? Apparently, it's more concise and readable, which I think is subjective. Does anybody else have any questions that we want to ask ChatGPT?
I was kind of working alongside on Gemini over here. It's just that if you're dealing with multiple items that you want to destructure out of an array or something like that, you can use it for that alternately. So you
Okay.
can put 2 or 3 characteristics within the curly braces. And
Interesting.
so if you had
Which
a
was,
huge
yeah.
list of ones, yeah.
on the example, they use it to take out 2. Not that one. When you looked it up on Google, they use it to take out 2 of the attributes.
Was it this one?
I think it was the third one.
I
Oh,
see.
maybe not. Oh, well, that's the key and value pair from object. So yeah, basically, but you can do it with objects, I guess. Or maybe not. Never mind. Oh wait, no, yeah, those are curly braces. Yeah.
Yeah, apparently if you use regular brackets, it'll extract the values associated with those items rather than a property. So if you're not looking to pull out, for example, the dot length property, if you wanted to pull out the actual values, then you would put it in regular braces or regular brackets.
Right. Interesting. I don't think we cover destructuring so much in the JavaScript portion, but we will be covering destructuring when we get to React, specifically when we get to passing properties down from one component to a child component. But basically, the more you know. I think you all asked very good questions about the code here, and that's exactly the kind of line of thinking that you want to have and hold on to throughout today's challenge and in general as a programmer. The better you are at asking questions, the more illuminating your path to success or something along those lines. Cool. So let's see, where else are we? Here, let's go back to today's README. It says to take a look around, which we did. Yes, there are also a lot of other files typically in a repository. So I jumped straight into index.js, but let's take a look at some of the other files here. So we see files that are preceded by a period. These are typically hidden files, at least on a Mac operating system. And you could assume then that they are configurations or files that don't necessarily relate to the actual operation of the code itself, but the handling of the code, the handling of the repository, etc. Like git ignore, which you should all probably be familiar with already, for example, tells us what not to include in a pull request. So node modules, for example, these are all the libraries that get installed whenever you, same with yarn.lock, these are the libraries that get installed when you run npm install. There is no point in uploading these files because that could just take up a lot of extra space. The whole point of having package management is to be able to just install all of these files when you pull a repository down to your local machine. So that's why we ignore those. Let's see, git attributes, something about text being set to auto, end of line being set to LF as opposed to CSRF. What else? An editor config. Usually you could discern just from like looking through these files what their purposes are. And when you get to a file that you really don't understand, again, that's where Google and ChatGPT come in. In this instance, I don't think there's anything here that you guys are not already familiar with. But you tell me, is there anything in this file tree that looks really, I don't know, alien or foreign to anyone here right now? Can anyone tell me what index.d.ts is?
I don't know what the D is, but it's a TypeScript file.
True, exactly, yes. What is the D, though? That is a very good question. .d.ts
the
declaration files. They exist for one purpose only, to describe the shape of an existing module, and they only contain type information used for type checking. Interesting.
feels like that's TS config file, except renamed.
Yeah, possibly. Let's take a look at this actual file. So we're defining an array, which is a param. Array 1 and array 2 are params. Yeah, looks to me like it's just declarations declaring what types are used in this script. I don't think we touch upon TypeScript too much yet in the curriculum. We're trying to work on that and add more TypeScript. But if you don't already know, TypeScript is essentially a much more verbose and declarative form of JavaScript. And it can be frustrating at first, but I think people generally tend to, it grows on you. Once you get past a lot of the initial frustrations of having to declare your type over and over again, it really does in the end help to prevent and catch a lot of errors before they get out of hand. So that is array equal, a very simple package. So let's try this again with maybe something a little more complicated, because we were able to find the main entry point there. We were able to get a high level understanding of the code. And we even asked ChatGPT for its opinion or its input on a few lines of this code. So let's see. Ooh, actually, this did look unfamiliar to us. So we did all these things. We thought about that line in particular. Sandy asked a very good question about it. A few others chimed in, and then we asked ChatGPT. Criticism and questions. Once you have a pretty good handle on the contents, you start asking deeper questions about the code, which I believe we did. And experimentation with the code. If it's code from an open source repo, you have access to it, so you could pull it down, play with it locally, and then you could also write tests. These are ways to help you understand a code. So maybe for something like this, something very simple, that's not necessarily the case. I was trying to think of a good example. I'm not sure if I found any. I know last quarter, a few quarters ago, I was wrestling with an API auth gem in Ruby. Every time I made an HTTPS request, an API request to one of our endpoints at work, it would get denied, and it was driving me crazy. I couldn't understand why. So I had to really dig through this code, for example, to try and understand why my request wasn't working. But I don't think this is a great example. It's first off, the documentation is very wonky. Notice there's a list here, but we're missing item number 4 on the list. These stocks were driving me mad, let me tell you. And it was a multi-step process where basically you had to do some hash conversions in order to get the gem to validate a request. And it was something that drove me crazy for the entire quarter. So maybe not the best example. Then I thought about Next.js, which might not be another example because that's way too many files. React 3 Fiber. I'm not sure if this in particular has an entry point, because this is actually more a collection of different methods and tools you could use when working with Three.js in React. So if there's no entry point, what is there? We have some docs, which I don't know if, yeah, it looks just like markdown files, more markdown. Really, this just consists of a lot of, I think. Ah, there we go. Some sub packages. So React 3 Fiber in the subdirectory, this might have an entry file, and there we are. There we have it, an index.tsx. So what does this thing do? It exports a lot of everything that it contains as types, apparently. It then imports from React 3 Fiber, or as React 3 Fiber from these types. It exports these additional types. And because this is really a library that you could use that contains a lot of imports, this is why we're really just seeing nothing but exports and imports here. At its core, React 3 Fiber is a wrapper that converts a lot of Three.js into React syntax. So 3JS again is just a really cool, lightweight tool for rendering 3D objects from a browser. And it is written in vanilla JS, which is why we need something like React 3 Fiber to utilize it in React's component structure. You could utilize 3JS in React without React 3 Fiber, but React 3 Fiber was designed to make your lives much easier. So that's why there's all these different things that you could import and use in your projects. So that's essentially all React 3 Fiber is, just a bunch of imports and exports. So, what else? If we go to the challenge, I think it gives you a few examples to use. It also says find a repository of your choice, which I think might be a good time to ask now. Does anybody have any examples in mind? Is there any code that anybody's been looking at that we could maybe run through for like 5 minutes?
It might be too much, but I've been messing around with the Python turtle.
Okay.
To like make drawings and whatnot.
Oh, that sounds awesome.
It's like yeah, it's pretty user or like beginner friendly, I think. Or at least some of the stuff.
All right, let's take a look. So already we could tell that's very well documented. But since this is about reading code and not reading documentation, let's take a look at the code. So again, very good documentation, a lot of details, a lot of explanations about what this is. It's a popular way for introducing programming to kids. It was part of the Logo programming language developed by Wally and Seymour something in 1966. Wow, so it's got a history. Imagine a robotic turtle starting at 0, 0 in the XY plane. After an import turtle, give it the command turtle.forward, and it moves on screen 15 pixels in the direction it is facing. Cool. All right. So now let's get down to the code. It looks like there are a lot of classes and functions. We have something called config.dict, which takes a file name, converts the contents of a config file into a dictionary. Okay. Then it has a method for reading config.
Yeah, I guess I should have said like the documentation I was reading was like how to kind of like the methods to controlling the object on the screen and stuff. Because all this, yeah, I kind of skipped a lot of this. I wasn't too sure what it was, but there's like a whole section where it's I forget where exactly, but like the different methods included that help you.
Sure. Yeah, we could take a look there. Before we go there, I was starting to actually wonder, so because some of these first methods are converting files into dictionaries, is it kind of like an SVG where an SVG opened up in a text editor is really just a series of numbers and it's read by the SVG compiler in order to render an image? Is it kind of similar to that? Is there like a turtle file that you create that essentially instructs this interpreter on how to move around the turtle?
So what I did was like you import screen, or I'm sorry, no, you import turtle and then you can create a screen which will, like when you run the code, it'll actually do a pop-up or a pop-up screen.
Okay.
And then you create your instance of turtle, and then you give it a shape, and then you can like have it just move and stuff, and then kind of like draw or have multiple. I think like what I'm trying, well, not really trying, but going through like a tutorial, like you can make a snake game out of it. So that's kind of what I was what I was doing.
That's pretty cool. Yeah. Yeah, where are some of these, like let's say the canvas, for example, where can I find the source code for that?
So actually the code I was reading was on like the actual site that you first had. Yeah, so in here, which I'm sure it's in the GitHub as well, but like if you just search for maybe, let's see. If you scroll down just a little more, that's where all the methods keep going. Let's see. Oh wait. Oh, almost there, I think.
Okay.
Yeah, right here.
Oh, nice. Okay. Cool. So once you import turtle, you could then run these methods to move the turtle around. Again, I kind of want to see, because we're trying to understand the code. Let's see if we can look for the source code. Turtle.py is the thing that gets imported, right? So it's got a list of the methods. What else can we look through? Let's see if we could find one of these, like forward methods, for example. So let's forward methods. There we go. So once we get down to line 304, we see how the forward method works. It takes these parameters from class to class, a two part. And if we go back to the code, let's see how that lines up. So it says forward takes a distance, and distance is just a number. It's either an integer or a float. Oh, so this is different. This is forward methods. I wonder if there's just yeah, as you can see.
Oh, so it's like down like, yeah, I'm at like 1600, and that's kind of where the, yeah, like the easier to understand methods are, like right, like bat, yeah, so right there.
There we go. Okay. So now we have the methods that are being referenced in the documentation. All it takes is a distance, just like docs say. And of course, it's Python, so it's got to initialize itself. And we have some more documentation on how this works. Bunch of commented code. Pretty cool. So yeah, this is essentially the lesson. Like, this is the goal for today, to look through existing code bases and to learn how to navigate that code, to understand the structure of that code, to know not just how to understand it from the documentation, but from the code itself as well. Any questions? Cool. I'll try to come up with some other examples of code bases to reference, and I'll make a list, maybe even create it as a second challenge or something. But until then, we can call it here. We could take a break, and then once you guys are back from your break, you'll have your breakout rooms. Sound good? Cool.